These are the answers to Section 3, the non-calculator section of Practice Test number 3, available on the College Board website. Again, this is Section 3, non-calculator from Paper Practice Test number 3. Number 1, a painter will paint in walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH, where N is the number of walls, K is a constant with units of dollars per square foot, L is the length of each wall in feet, and H is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression will change? This is less math and more just logic. Looking at what these four variables represent, our first variable here, N, is the number of walls. Does the number of walls change if you use a more expensive brand of paint? No, it is not N. Length and height, the length and height of the wall in feet. Do the length and height of the wall change if you use a different brand of paint to paint them? No. Length and height are out. K is our last one standing. Let's make sure it makes sense. K is the units of dollars per square foot, how much it's going to cost to paint each square foot. If we are using a more expensive brand of paint, that cost per square foot will change. K is our answer. Number 2, if 3r equals 18, what is the value of 6r plus 3? They're asking you first to solve for r using 3r equals 18. Since 3 times r equals 18, we want to undo that by dividing both sides by 3. We are left with r on the left and 18 divided by 3, or 6 on the right. Now that we know r is 6, and this is where you want to be careful, because look, they've put 6 as an option. They're wanting to trick you and go, r is 6, I've got my answer. Nope, they did not ask what is r. They asked what is 6r plus 3. So that's what we need to do. What is 6 times our value of r, which we discovered was 6, and then we add 3. 6 times 6 is 36, plus 3 is 39. Our answer is D. Moving on, number 3, which of the following is equal to a to the power of 2/3 for all values of a? They're testing as to whether you know exponent rules. The exponent rule says that if I have a number that is to the power of a fraction, it is the same as the denominator becoming the root and x becoming the exponent if I put that base a under that root. So again, this fraction, x becomes your exponent, and the y here, the denominator, becomes your root. This is just an exponent rule. So let's put in those values they gave us to the power of 2/3. Our denominator, 3, will become our root, and 2 will become our exponent. There's no real math to do. They just are testing whether you know that exponent rule. So our answer is D, the cube root of a squared. Number 4. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between 1776 and 1849 and X states joined between 1850 and 1900, which of the following equations is true? Word problems. Don't you love them? Probably not. Most people don't. So our first one, and I'm just going to write this here just so you have a nice visual. We have from 1776, to 1849, there was a number of states. We don't know how many. Then there was a second period of time, 1850, these dates, man, 1850 and 1900. Now, they're telling us 30 states joined in this time. It's okay, so we'll write that. 30 states joined in this time. Then they also say X states, an unknown number, joined in this time. All right, so those are our two variables, our two quantities we're dealing with. Now let's go back and read that first sentence again. The number of states that joined in this time period, 1776 and 1849, is twice the number of states that joined in this. Whenever we're setting up equations to represent these word problems, when you see the word is, this is that, that's a cue that there's an equal sign there. So first, the number of states that joined between 1776 and 1849 is, all right, well, we're told that first number, 30, so we're going to plug that in. So 30 is twice the number of states that joined in this period. Twice the number of means I'm multiplying by 2. And how many states joined in that period? X. So this is a representation of the number of states that joined between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. And let's look and see, and there, B, 30 equals 2x or 2x equals 30. They are the same. That is our answer. Number 5. If 5 over x equals 15 over x plus 20, what is the value of x over 5? Anytime I see a fraction like this, I want to get rid of that fraction as quickly as possible. The easiest way to do it, where you have an equal sign in between two fractions and variables are involved, is you cross multiply. So I'm going to be multiplying 5 times x plus 20 and then x times 15. So on one side, doesn't matter which side, I'll have 5 times x plus 20. On the other side, I'll have x times 15. I'm going to write that as 15x. Now I need to distribute this through. So 5 times x is 5x. Then 5 times 20 is 100. And this is equal to, on the right, that doesn't change, 15x. So now I need to solve for x. I want the 100 to be by itself, and I want all the x's to be over on the other side. So I'm going to subtract 5x to get rid of it since it's being added over here. Let me zoom out a little bit, give us a little more room. Oh no, I can see number 6. All right, so I'm going to subtract 5x from both sides, leaving me with 100 on the left and 10x on the right. Then I need to get rid of that 10 that's in front of the x. So I'm going to divide both sides by 10, and I get that x is equal to 10. Once again, they are trying to be tricky, and they are giving you 10 as a possible answer because they want you to get to this point and forget that they didn't ask for x, they asked for x divided by 5. Always go back and reread the question before you put your final answer in. They are tricky. So now that I know x is 10, I can give them the answer to what is x divided by 5, or 10 divided by 5, which is 2. My answer is C2. Number 6, 2x minus 3y equals negative 14. 3x minus 2y equals negative 6. If xy is a solution to the system of equations above, what is the value of x minus y? Again, it's another one of those where they're not asking for x and y. They want you to find them and then do something with them. In this case, subtract y from x. This is a system of equations. Systems of equations can be solved through substitution, elimination, graphing. For this one, since we don't have a calculator, I'm not going to recommend graphing this by hand. Just looking at it, my instinct, just from having done this for a long time, is that substitution is going to be a little more work intensive and time is the essence here. So I'm going to go for elimination. Unfortunately, there isn't a really straightforward or simple way to eliminate things. And when I say elimination, we're trying to get either the x's or the y's to cancel out when we add these two things together. So I want them to match but be opposites. So I'd want one to be, for example, a positive 5x and the other one be a negative 5x. So they cancel out. I'm just left with y's, one variable, and then I can solve for that one variable. In this case, again, there's no real easy way. Both my y's are negative, both my x's are positive, and I can't multiply 2 by something to get to 3 to make that easy to cancel out, and I can't multiply 2 by something there again to get to 3 to make those cancel out. So I'm going to have to multiply both of these. I know, it's a pain, especially when the clock is ticking, but you got to do what you got to do. So I want a common factor to make it so that things can cancel out. I'm going to cancel out the x's, and 2 and 3, the lowest common multiple, I should say, not factor, the lowest common multiple would be 6. And I want them to cancel out, so one needs to be a negative 6 and one needs to be a positive 6. So on top, I'm going to multiply everything by a negative 3 because that's going to turn my first term into a negative 6. And on the bottom, I'm going to multiply everything by 2 because that will make my first term a positive 6, and those two will cancel out. So first, I'm going to go through and multiply this by everything. I'm going to write it down here. Negative 3 times 2x is negative 6x. Negative 3 times negative 3y is a positive 9y. And negative 3 times negative 14 is a positive 42. On the bottom, I have 2 times 3x, that's a positive 6x. 2 times negative 2y, that's a negative 4y. And 2 times negative 6 is a negative 12. Be super careful with these positives and negatives. You do not want to get this wrong because of a careless error. Those are the ones where you just want to kick yourself because you're like, oh, I knew how to do this. We don't want that to happen. So now I need to add these together. Again, as I planned, the x's cancel out. 9y plus a negative 4y is 5y, and 42 plus a negative 12 is a positive 30. Since 5 times y equals 30, I'm going to divide both sides by 5 to discover that y is equal to 6. Now that I have my y is 6, I can figure out what x is. I can use either of these two equations. I'm going to use the first one and say 2x minus 3y equals a negative 14. If y is 6, I'm going to just replace that there. So 2x minus 3 times 6 is 18 equals a negative 14. So 2x minus 18 equals negative 14. I'm going to add 18 to both sides, and I get that 2x is equal to 4. Divide both sides by 2 to get rid of that 2, and I find that x is equal to, a very sloppily written, 2. Now that I know x is 2 and y is 6, I can answer their question. What is x minus y, or 2 minus 6? It is negative 4, and that's my answer. Moving on. Number 7, the function f is defined by a polynomial. Wow, be a little more vague, please. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? Now, they're not telling us what kind of polynomial. It could be a quadratic. It could be an x cubed. We don't know what it is. They're just wanting to know what must be a factor of this. Now, when you have a factor of a polynomial, like let's say it was the polynomial x squared plus 3x plus 2, and you factor that, you're going to get x plus 2 times x plus 1. Now, if you graph this polynomial, you're wanting to know where it crosses the x-axis, where its zeros are. That's what those are called, where they cross the x-axis. You're going to factor it, and you're going to say, where do these individually equal 0? So if x plus 2 were to equal 0, x would be negative 2. So it's going to cross at negative 2. Then if x plus 1, and my little thing is going haywire, there we go. If x plus 1 is equal to 0, this second factor over here, then x would be a negative 1. Oh, it's also crossing at a negative 1. So I know this parabola has those two zeros. That's the connection. Factors indicate where the zeros are, where it crosses that x-axis. Now, what is true about any coordinate on the x-axis? No matter where it is on the x-axis, y is going to be 0. Everywhere on here, y is 0. So I'm going to look at this chart, and I'm going to find a place where y is 0. When we're talking about a function, f of x is the same as y. It's the number we get when we input the x value, and it goes through the little, goes through this calculation, and it spits out a number. That number that it spits out is the y value, or the f of x value. So where is f of x 0? Right here, where x is 4. So 4, 0 is a 0 of this polynomial. So I know I've got this polynomial, and at 4, 0, it's crossing. I don't know anything else about it. I don't know if it's going like this. I don't know if it's going like that. I don't know if it's going like this. I don't know. But I know it's going through that spot, that 0. So what must a factor of it be? Now, just to look at this, you can kind of If you're looking at the answers, I bet you can guess without doing any further math, since we want it to be 4, what's the only one that has 4 in it? C. And yes, that is our answer. But if you're looking at this for the actual real mathematical reason as to why this is true, if you notice in our factors here, we were finding where this factor was equal to 0 and then solving for x. So if we're working backwards and trying to get from the x back to that factor, I'm just going to erase this to kind of show how I would do this going backwards. There we go. So I don't know what that is right there. I do know what x is. I'm at that point where I found out that x is equal to 4, but I don't know this number. I'm just going to call it a. I don't know what a is. There we go. But I do know that x is 4. So then I would plug that in right here and say 4 plus a equals 0. What is a? Subtract 4 from both sides, and you get that a is equal to -4. So that's what I would plug in here as my factor, x minus 4. So there's the mathematical reason, though. As I said, logically, as soon as you figure out that 4, 0 is the one you're looking for, the only multiple choice answer with 4, yeah, that is your right answer. Right, number 8. The line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the points c, d, where c is not 0 and d is not 0, what is the slope of the line in terms of c and d? So I have this line. I don't know the slope. They're telling us y equals kx plus 4. This is in the format y equals mx plus b. When lines are in this format, m is your slope and b is your y-intercept. So we don't know the slope. We have no idea. But we do know the y-intercept. It's 4. So that means I have this line that's going through that point. So I know that a point on this line is 0, 4. Now I'm also told there's another point on this line, C, D. Neither of these are 0, which is nice, okay. What is the slope? The formula for slope is change in y over change in x, or rise over run. What this means is you take your two y values, you put them on top, subtract them. Take your two x values on the bottom, subtract them too. For example, if I had the points 1, 2, and 4, 5, and I wanted to know the slope, I would say the y values, 5 minus 2 on top, and the x values, 4 minus 1 on the bottom. And you can change the order and you will still get the same slope. You just have to make sure you're starting at 1 and then subtracting the other, or you start at this one and subtract that one. It doesn't matter either way. So you could do the alternate 2 minus 5 on top and 1 minus 4 on the bottom. You still will get the same slope. So that's what you have to do. Just the only difference here is we're not using numbers. We are using some numbers, but then we're using some variables. So I'm going to do that same thing. I have my 2 points, 0, 4, and C, D, and I'm going to start with this one and subtract those. The y's go on top. So D minus 4 on top, and then C minus 0 on the bottom. Since we know that C is not 0, we're told that over there, I can just say C minus 0 is C, and D minus 4 stays the same on top. So D minus 4 over C, or A, is my answer. Right, number 9. Kx minus 3y equals 4, and 4x minus 5y equals 7. In the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solution? This one I think you kind of have to have almost like a eureka moment when you're thinking about this, and not think about them necessarily as just equations, but think about what they would look like if you graphed them. X's and Y's and constants. These are lines. If I have a system of equations and I'm solving it by graphing, what is that? If I have two lines and I say, what is the solution to the system of equations, these two lines? If I graph those lines, I'm looking for where they cross. That point of intersection, and with lines there's only going to be one, that point of intersection is the solution. So they want us to know, for what value of k will there be no solution? Well, How can you have two lines on a plane that never cross? There is only one scenario where two lines in a plane don't cross, and that is when those lines are parallel to each other. That is it. They have to be parallel. So you have to think of it in terms that these two equations represent lines, and we want to put in a value for k that will make them parallel to each other. Now, I think it's easiest to deal with slope if the lines are in slope-intercept form. So that's what I'm going to do. I'm going to change both of these into slope-intercept form so I can very easily see the slopes of these two lines. So first here on the left, to put it in slope-intercept form, you just need to isolate y. So I'm going to subtract kx from both sides, and that gets me a negative 3y on the left, and on the right, negative kx plus 4. To get rid of that negative 3, I need to divide everything by negative 3. And I am left with y equals, those negatives there cancel out. And so I am left with k over 3x minus 4/3. My second equation, 4x minus 5y equals 7, I want to do the same thing and get y by itself. I'm going to subtract 4x from both sides, which leaves me a negative 5y on the left and negative 4x plus 7 on the right. Then I need to divide everything by negative 5 to get rid of that negative 5. That's in front of the y. And I am left with y equals, negatives cancel out, 4/5 x minus 7/5. Now at this point, those negative 4/3 and negative 7/5, they don't matter anymore. I have put these both into slope-intercept form, so I have my slopes. That's all I need. K over 3 and 4 over 5. Parallel lines have the same slope. So this is what this problem is really testing. They're testing you to know that a system of equations with an x and a y represents lines. For them to have no solution, the lines cannot cross. They must be parallel, and parallel lines have the same slope. So I need to set these two slopes equal to each other and then solve for x. Solve for k. So k over 3 is equal to 4 over 5. Just like an earlier problem in this section, cross multiplying is the way to go. I'm going to cross multiply. 3 times 4 is 12. 5 times k is 5k. And then I'm going to divide both sides by 5 to get k by itself, and k is equal to 12/5, which is A. There's my answer. Onwards. Number 10. In the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points A and B. What is the length of line AB? So visualize this. We have a parabola x minus 11 squared. This is a positive parabola because I'm going to have a positive x squared. And that parabola is going to be opening up because that's what positive parabolas do. And there's a line that is y equals 25. That is a horizontal line. So I have a horizontal line that's cutting perfectly across this parabola, and it's intersecting at 2 points. We want to know how long that is. So if I find the x-coordinate at this point and the x-coordinate at that point, it'll be very easy to tell the difference. I can just subtract. Like say if the x-coordinate here was 5 and over here was 25, how far is it between those? 25 minus 5, or 20. So how do I find the x-coordinate at those points? Well, we're told that the line is y equals 25. So that means I'm putting an x in and I'm getting 25. So x minus 11 squared must equal 25 because it's y equals x minus 11 squared. So to solve this, I'm going to take the square root of both sides, and I get x minus 11 equals, square root of 25 is 5, but remember that could be positive or negative when we take a square root. You have to remember that. So now I have two options, and I'm going to separate those. X minus 11 equals a positive 5, and x minus 11 equals a negative 5. To solve this one on the left, I'm going to add 11 to both sides. X is alone on the left. 11 plus 5 is 16. Second one, I'm again going to add 11 on both sides. X is left alone. Negative 5 plus 11 is 6. So now I have my X coordinates. At this point here, X is 6, and here, X is 16. How far is it from 6 to 16? 16 minus 6 is 10. My answer is A, 10. Number 11. Note figure not drawn to scale. This is important. Whenever they say this, basically don't assume that anything you're seeing is true. What this means when it says not drawn to scale is what it could be in reality is it could be more like super skinny like this. And then I'm just drawing this terribly, but it could be like this really big gap like that. It could look more like this in reality. Here it's being drawn. It looks like they're all equidistant. You know, they're what's the word for that? Those angles are all equal. We'll say that. It looks like those angles are all congruent, that they're probably all 60 degrees. But that right there, not drawn to scale, don't count on anything you're seeing. Just ignore it. It's just to give you an idea of how these things are in relation to each other, but those angles are not accurate at all. Here's our problem. In the figure above, lines K, L, and M intersect at a point. And I'm going to break out the ruler because, I mean, I've obviously just shown that you can't trust me to draw a straight line on a computer screen. Funnily enough, I actually can draw in real life, but, you know, on a stylus on a computer screen, not my forte. Freely admit it. Right, so we have our 3 lines here, and we're just doing a nice little approximation because it's easier, I find, and I do this even, you know, if I was taking the SAT, I would sometimes redraw things just to really wrap my head around it. So we have K, L, and M, and we have X, Y, Z, T, U, and W. In the figure above, they intersect at a point. If X plus Y equals U plus W, which of the following must be true? Now, so that's what we're given. So I'm going to write it over here. X plus Y equals U plus W. And then we have these 3 options. Which of the following must be true? Not might be true, not could be true, must be true. If there's any exception, if there's any time when it's not true, it's out. And we're going to check and see, does X equal Z? Does Y equal W? Does Z equal T? Now, they are not giving you all the information you need to know. There's one piece of information you have to bring to this, and that is the knowledge that if you have 2 intersecting lines, then opposite angles, sometimes called vertical angles, are congruent. The ones that are across from each other on that intersection. So in this little one down here, these would be congruent and these would be congruent. Again, your book may call them vertical angles or opposite angles. I've seen it both ways. So knowing that, we're going to go through and mark this up. So here's these 2 are vertical or opposite angles. So I'm going to mark them. And I'm going to write over here, X is equal to T. Then these are the same. W is equal to Z. And last but not least, these are the same. So Y is equal to U. Now we are trying to get to X equals Z, Y equals W, and Z equals T. I'm going to start with X equals Z. Now, I look at this over here. I'm like, okay, so this is what we're given, and these are what I know. So I can swap in. So like if there's a T, I can put in an X. If there's an X, I can put in a T. If there's a W, I can put in a Z. If there's a Z, I can put in a W. If there's a Y, I can put in a U. If there's a U, I can put in a Y. Okay, so what happens if, I'm just going to start playing around with this and see if I can get close to any of these 3 postulates, these 3 statements are making. If Y is equal to U and I plug it in there, if I plug in a U in for Y, what would happen? All right, well, I'm going to write that down here. So we have X plus Y equals U plus W. And since Y equals U, I'm going to replace that Y with a U. There we go. Now I've got a U on both sides. So if I were to subtract U from both sides, those U's would disappear, right? And I would be left with X equals W. Now that isn't any of those three, but that's an additional useful piece of information that I've just figured out. So I'm going to add that to my list, that X equals W, because that might help me. Okay, so now these are my pieces of information that I figured out. Am I any closer? I haven't proven any of these three yet, but I'm closer, especially to this first one, X equals Z. Because see, I've got X equals W and W equals Z. It's a thing in algebra where if you say if A equals B and B equals C, then A equals C. Does that look familiar? That sort of principle, that's what we're dealing with here. So we have X equals W from there, and I have that W equals Z, so X equals Z. All right, we've established that. Number one is correct. Number one must be true. The next one, Y equals W. Y equals W. To get from here to Y equals W, I'm going to have to get rid of the X and the U. Is there anything I can do to get rid of that? Well, I know that X equals T. Does replacing T in there change anything? No. If I replace Y equals U, if I replace that with Y, nope. I'm not trying to get rid of the Y. Just trying to get to Y equals W. The U and the X, it doesn't seem like there's anything really there that we can get to. There's even something else we can learn about this. If we look at this graph, this chart, this drawing, I'll get it right eventually. Another thing you can see because of these vertical angles, you could just look at these two lines intersecting, which means this angle is equal to that angle. And you can do that all the way around. So you can do all these combinations like X plus W equals Z plus T. Or you could say X plus Y equals U plus T. That you can say U plus W equals Y plus Z, because it's U plus W, Y, Z. These are all these combinations that we can do. But if you go through all these, there's no way to just get Y and W. There just isn't. And we can kind of see this. This problem, honestly, it's one of those of diminishing returns, because you can really get in the weeds and try to come up with all these different ways and how can I do this? This is the kind of problem, honestly, I would circle it and come back to it at the end if I have additional time, because this sort of like hypotheticals and what are possibles must be trues. It's really easy to spend a ton of time trying to think of all possible scenarios that might prove this one false or that one true. You know, it's a true-false question times 3. And those are time sinks, and you really don't have the time to waste on these. So this is the way that you logically prove it, that you can prove to yourself which one, try to come up with a combination, for Y equals W, and you're not going to find one. There's a lot of different things you can try here, and you're not going to find it. Another way you can look at it is if you view this graph, because it's not drawn to scale, what would happen if I moved this line, so this tilts this way, and this line kind of goes in like that? What would happen? Let's just try it. So if I did, and I really made this a really sharp angle right here, really kind of sharp, really exaggerate that. So after I've done this, look at our original sort of postulate here. X plus Y equals U plus W. Could that still be true right here? Could X plus Y equal U plus W? What if I picked some numbers? What if I said X is 80, Z is 80, W is 80, T is 80, and Y and U are 20? Would what they told us be true? Would X plus Y equal U plus W? X plus Y would be 100. U plus W would be 100. That would be true. Is Y equal to W? No. Honestly, that I think is probably the best way to look at this and be convinced in your head that number 2 is out. It's not a must be true situation. Because again, frankly, you can spend so much time going through this and trying all these permutations. And I'm sure there's some that I didn't write down there in my little haste to just kind of write all these combinations. I'm sure there's some I'm missing. Yeah, this isn't a great problem. Not going to lie. It's not my favorite problem on this test. I don't think it's a really good measure of your math skills. Go back to the way it was. I just don't. It's my personal opinion. Don't come at me, College Board. Just not a fan of this problem. All right, so we cannot say that y equals w must be true. Last one, z and t. At this point, honestly, I always say to look at your multiple choice answers if you are given multiple choice answers, because sometimes you can take a shortcut. And I'm not saying this to say don't learn your math. I'm saying in the pressure of a test situation, use every tool at your advantage. Why not? So in this case, as soon as I've eliminated number 2, I've found that number 1 is true and number 2 is false. I'm going to look at my answers before I even try to go through this whole mess and see if I can prove 3. Because look at my answers. 1 and 2 only. Nope, that's out because I've just proven 2 doesn't work. 1 and 3 only. Okay, that's still possible. 2 and 3 only. Nope, that's out because number 2 doesn't work. 1, 2, and 3. Nope, that's out because 2 doesn't work. I've already got my answer. I don't even have to figure out if z equals t. The answer is B. If you're wondering why z equals t, it's going to be, I'm going to eliminate the ones that are extraneous at this point. You are going to be replacing the w here with a z, using that. So we do that, let's go boom, and that becomes a z because of w equals z. X equals t means I can replace this x with a t. And then y and u are left, but y equals u, so I'm going to replace that y with a u. Then the u's cancel out because I have a u on both sides, subtract from both sides, and I'm left with t equals z or z equals t, either way. So that's how you prove that one. But again, this is such a lengthy problem. That is how you do it. I honestly think you're better off just trying to visualize it and kind of picture in your head, especially for that part 2. Okay, what if they made these really tiny? Can I think of a scenario where these don't work? I can't tell you how little I like that problem. So I'm sorry you had to deal with it. You know, I didn't write it, but I'm still sorry. Okay, number 12. Y equals a times x minus 2 times x plus 4. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? Right. So when we're doing the vertex of a parabola, we want to find first the axis of symmetry. You find the axis of symmetry. The formula is it's negative b over 2a. And that's your vertical axis of symmetry. When we say axis of symmetry, we're talking about if we have a parabola, and it's that line that goes right smack down the middle. And if you drew your parabola correctly, which I didn't, it's going to divide it into 2 perfect and symmetrical halves. That is your axis of symmetry. And it always, this is why we care, it always goes through the vertex. So if you find that x line, that is the axis of symmetry, you have found the x coordinate for your vertex. Woohoo! It's my favorite way to find the vertex. Some teachers prefer others. I don't. I like this way. So negative b and 2a, where do those come from? Now this is not referring to that letter a that's over there. This is referring to when a quadratic is in the form ax squared plus bx plus c, where a, b, and c are constants or just numbers. This is not in that form, so we can't find the vertex just yet. So what you're going to do is you're going to multiply all this. So to multiply that, ax minus 2, x plus 4, I'm going to multiply a times both of these, and I get ax minus 2a, then times x plus 4, and then we're going to use FOIL, which is your first, your outside, your inside, your last, and multiply each of these one by one. First, ax times x is ax squared. Outside, ax times 4 is 4ax. Inside, negative 2a times x is negative 2ax. Last, negative 2a times 4, negative 8a. Okay, so we can combine like terms here. And we have ax squared plus 2ax. Since these are the same, ax and ax, we can subtract those. Positive 4ax, negative 2ax becomes just positive 2ax minus 8a. Okay, so in this equation, this quadratic, I should say, this is our first constant, 2a is our second constant, and negative 8a is our third constant. The a's here are not variables. They are constants. They are numbers. They're just sitting in for the numbers. The x's are the variables. The a's aren't. It's like a number with a mask on. So it's there. It just has a, like a little masquerade mask on, so you can't tell what it is. So I'm going to use that in my equation for the axis of symmetry, negative b over 2 times a. So this right here is my b, positive 2a. So I'm going to put that in on top because it's negative b, negative second constant over 2 times first constant. So second constant is 2a, so I want the opposite of that. That's what that negative means, is do the opposite. So that's going to be negative 2a. And then the bottom is 2 times the first constant. Well, the first constant is a. So 2 times the first constant is just going to be, this is not letting me erase, there we go, is 2a. Now, any variable or combination of variables that's over itself is canceling out. It's like 5 over 5, 100 over 100, 10 million over 10 million. They cancel out and it leaves 1. So we got that little negative, the negative stays. So this is negative 1. So this vertex, wherever it is, the x value is negative 1. Now, what are they asking for? Is that what they're asking? Negative 1? The x? No. They're saying that this vertex, the coordinates are c and d. So negative 1 is what they're calling c, and this unknown y value is what they're calling d. And that's what they want to know. What is equal to d? How do we find that? Well, we know that our c, our x value, is negative 1. So I'm going to erase all this. I know. Hope you took notes. So just go back to that initial, there we go. What we started with, a times x minus 2, x plus 4 equals y. That's our initial equation. So I need to plug in my x value into these two locations, do all this math, and I'll get my y, which is my d. You think they could have used more variables in this? Honestly, I think that's the hardest part of this, is just keeping all the variables straight in this problem. Right, so I'm going to plug in negative 1 wherever there's an x. So a times negative 1 minus 2 times negative 1 plus 4. Negative 1 minus 2 is negative 3. Negative 1 plus 4 is positive 3. Negative 3 times negative 3 is negative 9, and that a just stays along for the ride. Negative 9a is my answer, which is a. All right, on to 13. The equation 24x squared plus 25x minus 47 over ax minus 2 equals negative 8x minus 3 minus 53 over ax minus 2 is true for all values of x is not equal to 2 over a, where a is a constant. What is the value of a? Yeah, I'm not going to lie. This one takes a little extra writing, a little extra calculating here, a little extra time. It's definitely one of those where if I was under a time constraint, if I was afraid I wouldn't finish in the time allotted, I would circle this on my test booklet, because this is the paper version here. I would circle it, I would do the rest of it, and I would come back at the end if I had time. Anything that you look at and you do not immediately go, oh, this is going to take me a minute or less, or a couple minutes or less, those are usually best saved till the end. Do all the ones that are the quick ones first to make sure you get those maximum number of points. Now, first, the part here where they say x does not equal 2a, all that is telling you is, or 2 over a, excuse me, that it's not going to have a 0 in the denominator there. So you don't have to worry about that. Because if you put 2 over a in there, you're going to end up with, it's going to end up with 0. So we don't want that. So cool. Now that we know there's no zero, we have to worry about getting rid of these fractions because, fractions. We don't want fractions in this when we're trying to solve it, especially because we have some that are fractions in this one, the negative 8x minus 3, that isn't. So how do we combine everything and get rid of that fraction? First, we got to make this into a fraction before we can get rid of it. I know, it's crazy. So negative 8x minus 3, we want it to have that same denominator. When you want to give a denominator to something that is not currently in a fraction, you're going to multiply by that denominator over itself. Because anytime you do that, like if 5 over 5 or 5k over 5k, whatever it is, if it's the same thing over itself and it's not 0, then that's equal to 1. And you can multiply anything by 1 and it doesn't mess anything up. It's fine. So this denominator is ax minus 2. So we're going to multiply this by ax minus 2 over ax minus 2. That's equal to 1. We can do it. To multiply by this, we need to turn it into a fraction. So we're going to put it over 1. So on top, this is a FOIL situation. You're going to distribute, do your first terms, your outside terms, your inside terms, then your last terms. That's the FOIL acronym. It also means distribute. All right, so first, negative 8x times ax is negative 8ax squared. Our outside terms, negative 8x times negative 2 is positive 16x. Inside, negative 3 times ax is negative 3ax. Last, negative 3 times negative 2 is a positive 6 all over ax minus 2. And then we have over here, I'm just going to bring down the other components of this. That's the 53 over ax minus 2. And that's equal to 24x squared plus 25x minus 47 all over ax minus 2. Okay, since on the right-hand side, they now have the same denominator, we can combine things. Because I can do that with fractions. So I'm going to combine it. Yay! There we go, minus 53. Now, because these are both over the same denominator on both sides, I can get rid of it. That denominator is out of here. The reason you can do that is because I am saying I am multiplying everything by ax minus 2. When I multiply this by ax minus 2, it gets rid of this because this is saying divided by ax minus 2. I multiply by ax minus 2, it gets rid of it. Same exact thing happening on the right. I multiply all this by ax minus 2 because I have to do the same on both sides. And since this is all being divided by ax minus 2, multiplying gets rid of it. Thank goodness. All right. So that's now gone. Yay! Be gone, foul fraction. Now, what can I combine? What like terms can I combine? Well, over on the right, I have two constants, positive 6 and negative 53. If I add those together, I get a negative 47. And looky there, on both sides, I have a negative 47 on both sides. So if I add 47 to both sides, both of those 47s disappear. Woohoo! Now look at this. And that negative looks really bad, so we're going to do, boop, there we go. 24x squared plus 25x equals negative 8ax squared plus 16x minus 3ax. What they want you to realize here is we got rid of the negative 47s, and they were identical. Negative 47 on both. So nothing really weird is happening. If those numbers had been different, it would mean that these bits, were not equivalent to each other. But because they were both negative 47, these are equivalent. But that also means that each term, if you're talking about powers, the x squareds are equal to each other. The x's are equal to each other because those negative 47s were equal to each other. If there was something funky or strange going on, those constants would have been different. So all you have to do at this point, after all that mess, is just look at these two and set them equal to each other. So on the left, you have 24x squared, and it equals negative 8ax squared. I can divide both sides by x squared, and that gets rid of those x squareds. I'm left with 24 equals negative 8a. To get rid of that negative 8, I divide both sides by negative 8, and a is equal to negative 3. And if you want to double check that this works, you can double check it by looking at these second terms. See what happens if you plug negative 3 in right there. Then it becomes negative 3 times negative 3x, or positive 9x. And does 16x plus 9x equal 25x? Yes, it does. So that's confirmation that that is accurate. So that's a long walk to get to just a equals negative 3. Yeah, so that one takes a bit longer than some of the other ones. All right, number 14. What are the solutions to 3x squared plus 12x plus 6 equals 0? Right off the bat, and I do encourage people to do this who are studying for the SAT, always look at your answers first. You can get clues in the multiple choice answers that are provided to you. Here, every single one of these includes a square root, a plus or minus, and a square root. What that should tell you, if you are, if you've studied your factoring, is that this won't be factorable. You're not going to end up with a square root if it's an easily factorable, like, oh, it's going to factor into 3x plus 2 and x plus whatever. If you can factor it like that, you're not going to end up with these square roots. It just doesn't happen. If you see those square roots, it means you're going to need to use the quadratic formula, not factoring. So that will save you some time. If you look at those multiple choice answers and go, wait, there's all square roots, I should just jump to using the quadratic formula. I should not waste my time trying to factor by grouping or anything like that. So what is our quadratic formula? It is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And they do not provide this as part of the reference at the beginning of the section. It is not there. This has to be in your head, especially because this is not a calculator portion. So you can't just use your calculator and, ask it what's the solution to this. You have to know this. Sorry. I know it's kind of a monster of a little formula to remember, but you got to do it. So negative b plus or minus square root of b squared minus 4ac all over 2a. A, b, and c are referring to the constants. Here they are 3, 12, and 6. Those are our a, b, and c. So we're just going to plug all those in and then do the math. The hardest part of this is remembering that. The second hardest part is being careful when you're doing the math, making sure those negatives are done accurately, the plus minus, that you take that into consideration. Okay, so our b is a positive 12, so we're going to put the opposite of that first, which would be a negative 12, plus or minus. Again, our b is positive 12, so that goes in here, 12 squared, minus 4 times a times c. 4 times our a is 3, and our c is 6. All over 2 times a, again our a is 3. And now this is just about being very careful in your math. So inside here we have 12 squared. 12 squared, or 12 times 12, is 144. Minus 4 times 3 times 6. 4 times 3 is 12. 12 times 6 is 72. Especially for these non-calculator portions, if you are feeling rusty on your times tables, these non-calculators, it's so good to have these times tables in your head up to 12 times 12. It's going to save you a lot of time, so you're not having to figure these things out by writing them out. Okay, so 144 minus 72. Since we said this was a little shortcut here, this is 12 times 12, and this is 12 times 6. So if you subtract them, it's going to be 12 times 6, because 12 times 6 times 2 would equal 12 times 12. So 144 minus 72 then is going to be 72, or 12 times 6. Okay, so now we're in the simplification part. Also, 2 times 3 down here is 6. Okay, but as you can see, this does not match any of the answers, so we need to simplify this further. 72. Are there any perfect squares inside 72? If you don't know this offhand, factor trees are your friend. And you can start doing a factor tree and saying 2 times, it's even 2 times what? 36. At which point you might go, hey, 36 is 6 times 6. That's a perfect square. Here are those multiplication tables coming in handy again. But if you don't have that in your head, just keep doing a factor tree. Like say 36 might be 3 times 12. 12 is 2 times 6. 6 is 2 times 3. And you're looking for pairs of numbers. So you're like, 2 and 2, and 3 and 3. So 3 and 2, or 3 times 2, times 3 times 2. 3 times 2 is 6, so 6 times 6. If you like more details on factor trees, I'm going very quickly because there's so many problems here. I have links on all the topics that we're covering here, more detailed, in-depth on these topics like factor trees and quadratic formula and stuff, linked in the description below. Okay, so now I know 72 is 36 times 2. So, okay, I'll put that in there. It is 36 times 2. And now we can really start tidying this up. So I'm going to rewrite that as negative 12 plus or minus square root of 36 times square root of 2, because you can do that. One of those great things with square roots, with radicals that you can do. And what is the square root of 36? It is 6. Hey! So negative 12 plus or minus 6 times the square root of 2 over 6. But if you'll notice, that still does not match any of our options. So now we need to look for a greatest common factor. And you're looking for it not under the radical anymore. That is locked off. You can't touch it. You're looking at these 3 numbers. Is there anything that goes into all 3 of them? Or any of them? Yes, 6. So I'm going to pull out a 6 on top. So if I pull out a 6, what is negative 12 divided by 6? It is negative 2. What is 6 divided by 6? It's 1. So it just disappears. Now I have 6 times negative 2 plus or minus square root of 2 all over 6. Since this is saying multiply by 6, then divide by 6. Or if you know with your fractions, top and bottom can cancel out if they're being multiplied. Those cancel out. And I am left with negative 2 plus or minus square root of 2. Let's scoot that over. Boom. And that is option A. On to 15. C equals 5/9 F minus 32. The equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? 1. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Number 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. And number 3, a temperature increase of 5/9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. First thing, I say this a lot, look at your options. Their options are 1 only, 2 only, 3 only, or 1 and 2 only. All right, so there's not any sort of thing where we can say, if we can eliminate this 1, we can eliminate 3 options. Not as helpful as we'd like, but, just keep this in mind. It's either 1 or 2 or 3 or 1 and 2. Now, there's a couple ways to do this. Again, this is a timed test. Time is of the essence. You want to be as quick as possible. For this particular one, I honestly think the best way to do it is to think of it logically without doing the math of multiplying things through. You can if you want, but especially because you don't have a calculator. If you're multiplying something by 5/9 or 9/5, no one wants to be doing that, right? So, what do you know about Celsius versus Fahrenheit? Well, what is freezing in Celsius? It's 0. And boiling is 100. In Fahrenheit, freezing is 32. And boiling is 212. So if you're viewing this as linear equations, lines, which they are, because they are increasing at a steady rate, both of them, it's the same rate each time, so that is linear. Celsius, this is a gap. There's 100 degrees in here. In Fahrenheit, there's 180 degrees in here. So what does that tell you? If you're thinking about how they increase, is that Celsius is increasing more slowly than Fahrenheit. It's just going like put, and Fahrenheit's going, whoo, it's increasing much more rapidly. So C is increasing more slowly, and Fahrenheit is increasing more rapidly. Well, what are our 3 options here? a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of a degree of Celsius. That seems like that might be logical, right? Fahrenheit's increasing by 1 whole degree. Celsius is increasing by only 5/9. So like, okay, that's a possibility. Number 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees in Fahrenheit. Well, is that saying the same thing as number 2? Like, it's saying again that if the Celsius is increasing by just a little, then the Fahrenheit is increasing by more. Well, let's just see. I'm actually not even going to look at this up here. I just want to look at these two here. So 1 degree of Fahrenheit is equal to 5/9 degrees of Celsius. That's what the first one said. And the next one said 1 degree of Celsius is equal to 1.8 degrees of Fahrenheit. Okay, now me, when I look at this, I want everything to kind of be the same. So I want this to be fractions because I got a 1.8 and I got a 5/9. Well, what is 1.8 in a fraction form? This is the same as, I'm going to write it, I'm going to slide things up a little bit, 1 8/10, which would be the same as 1 4/5. And if I converted it to a fraction like this, you would say 5 times 1 plus 4 gives me 9 9/5. All right, so now it's saying that 9/5 degree of Fahrenheit is equal to 1 degree Celsius. All right, so how would I get from this to see if these are equivalent? Well, here I have 1 Fahrenheit and I want to get to 9/5. I need to multiply this 1 by 9/5. So if I multiply both sides here by 9/5, what happens? On the left, I get 9/5 F, or Fahrenheit. Here, 5/9 times 9/5. Those fractions cancel out, and I am just left with 1 Celsius. So this is the same. 1 and 2 are saying the same exact thing. So, it's starting to look like D is our best option, 1 and 2 only. Well, let's look at number 3, because what if I'm reading this wrong and maybe 1 and 2 are both wrong? They're saying the exact same thing. So either they're both right or they're both wrong. Let's look at number 3. A temperature increase of 5/9 of degree of Fahrenheit is equivalent to a temperature increase of 1 degree in Celsius. So that is saying that Celsius is moving up faster than Fahrenheit. Well, that's not true. Fahrenheit is moving up faster than Celsius. So it's saying part of a degree Fahrenheit, Celsius goes up a whole degree. That's obviously wrong. So 3 is out. 1 and 2 are both saying the same thing. They're both true, 1 and 2 only. Now I'm kind of overlooking the other thing that you might know. If you've worked with Celsius and Fahrenheit in your math class and you know this 5/9, 9/5, the 1.8, this may look very familiar and you may not have even needed to kind of prove this by going through this conversion to try to make sure that 1 and 2 are both saying the same thing. Yeah, if that's the case, that's great. That's great. But, not everyone remembers everything, because a lot of times, we have a lot of stuff we have to learn before these tests, and, things can be forgotten quite easily. It happens to all of us. So this is sort of a quicker, I think, logic-based approach. The other way you can do this, I think it takes more time, again, because you don't have a calculator, but you can absolutely plug in numbers up here and see what happens. So like if you plugged in, you started at 0 degrees Fahrenheit and you did this math, which actually, I don't think I would. I think I'd start at 32, so these would cancel out. That's what I think I would put 32 in there and, cancel out. And, just for giggles, I'll show you what happens there. If you do that, if you do this the long way. And again, this is dependent on you realizing that 32 is the best choice to plug in. If you put in other numbers, you're going to be in for a lot of painful multiplication. And I'm sorry. So let's say here, it says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of degree Celsius. All right, so let's say I'm going in Fahrenheit from 32 to 33 degrees. What happens if I put in 32? 32 minus 32 times 5/9. 32 minus 32 is 0. 0 times 5/9 is 0. So when Fahrenheit is 32, Celsius is 0. Which again, if you have those freezing and boiling points, you would have that in your brain, but that shows you the math of it. All right, so Celsius is 0. What happens when Fahrenheit goes up to 33? 33 minus 32 times 5/9. 33 minus 32 is 1. 1 times 5/9 is 5/9. So in Fahrenheit, we have 33 degrees Fahrenheit. We have 5/9 of a degree Celsius. So that proves number 1 is correct, that is accurate. At which point you could do what I showed you, where you try to see if number 2 is saying the same thing as number 1, which it is. You would know 1 and 2 only. The other way would be to put numbers in here again. Temperature increase of 1 degree Celsius. So you might start with what you already had, where when Celsius is 0, Fahrenheit is 32. So you go, okay, and let's bump Celsius up to 1 times 5/9 times F minus 32. And you would need to multiply by 9/5 on both sides. You get 9/5 on the left. All right, this 9/5 cancels out with 5/9, leaving F minus 32. And then you would add 32 to both sides. So Fahrenheit is equals 32 plus 9/5. Then you would need to convert 9/5 to a fraction or to a decimal and say that's 1.8. That's going to be 32 plus 1.8. And you go, oh, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Yeah, again, see, as soon as you get those fractions in there like that, I think it's a recipe for errors to creep in when you are doing this without a calculator and you're doing things quickly because, you're trying to speed along. So again, said it before, say it again. I think just looking at this logically about what you know about the Celsius and Fahrenheit scales, if you're not remembering, the relationship offhand, I think it's probably the best way to approach this problem. Number 16, x cubed times x squared minus 5 equals negative 4x. If x is greater than 0, what is one possible solution to the equation above? And this is not multiple choice. So first thing you're going to want to do is distribute this. I'm going to rewrite it over here so it'll be nice and clear. 5 equals negative 4x. All right, so first thing we're going to distribute. So x cubed times x squared is x to the 5th. X cubed times negative 5 is negative 5x cubed, and equals a negative 4x. If I'm going to try factoring this and solving for x, I want everything on one side and I want it all equal to 0. So I'm going to bring everything to the left. To do that, I'm going to add 4x to both sides. That will get rid of it on the left and leave me with 0 on the right. X cubed plus 4x equals 0. Now, first thing for factoring like this is you want to see, are there any greatest common factors? X goes into all of this, so I can pull out an x. So I'm going to zoom out a little bit. I'm going to need some more room. Pull out an x, and I get x times x to the 4th minus 5x squared plus 4 equals 0. Now, you may not have much experience factoring x to the 4ths, but here's something to look out for. If it's going down evenly, if it's, x to the 4th, then halved, x squared, then disappears completely. That pattern, because it's like x squared, x, nothing. It's that same pattern, 2, half, nothing, because it's x to the power of 1. You can factor it the same way as you do an x squared. Same principles. If this were x to the 4th minus 5x cubed, no, it would not work. This has to be half that exponent, and this has to be completely gone. No x squareds or x's. Then you can treat it the same way. The only difference is instead of starting with an x and an x when you're factoring, it's going to be x squared in both of them in this case, because that's that middle term, x squared. As you see, when you multiply them together, you get back to that x to the 4th. Right, so we're going to treat it just like a regular factoring. In regular factoring, we're looking for what multiplies to this, but adds to the middle term of middle constant of negative 5. So what multiplies to positive 4 but adds to negative 5? To add to a negative but multiply to a positive, they both have to be negative. So what are my factors of 4 that would be negative? That'd be negative 1 times negative 4, or negative 2 times negative 2. If I add those together, negative 1 plus negative 4 is negative 5. Negative 2 plus negative 2 is negative 4. All right, there's my negative 5. That's the one I wanted. So it's going to be, the factors are negative 1 and negative 4. So let me write those in. X squared minus 1, x squared minus 4. Now, what they want you to realize, well, actually, there's two ways you can look at this. You can say, just like with regular factoring, x times x squared minus 1 times x squared minus 4 equals 0. So any one of these could be 0. So I need to set them all equal to 0, and then I can solve this. So the first one would just be that x equals 0, and I don't have to do anything else. The next one would be x squared minus 1 equals 0. The other one would be x squared minus 4 equals 0. These you can do one of two ways. You can either, like for example, here you would add 1 to both sides. You get x squared equals 1. Take the square root of both sides. X equals plus or minus 1. It's probably the easiest. You also could realize that this is a difference of squares. It's that factoring terminology, difference of squares, which following the rule means you could factor it into x minus 1 times x plus 1. Then you set each of those equal to 0, and you get, when x minus 1 equals 0, then x would be 1. When x plus 1 equals 0, x would be negative 1. Same answer. And the same thing over here with x squared minus 4. You can solve it either way. Same difference. It's not letting me undo. There we go. I'm just going to use the square root method. So I'm going to add 4 to both sides. I get x squared equals 4. I take the square root of both sides, and I get x equals plus or minus 2. This is getting really messy, so I'm going to erase this. So we just have the last part of this visible. So what are my answers here? I've got, here we go. I've got x equals 0, x equals plus or minus 1, and x equals plus or minus 2. What does the question say? If x is greater than 0. So my three possible solutions, greater than 0, that one's out, that one's out, that one's out. 1 or 2, either of those will work. You can answer either one. Number 17, if 7/9 x minus 4/9 x equals 1/4 plus 5/12, what is the value of x? Couple ways to do this one. I'll show you my way first, and I'll show you the way the College Board recommended. I looked at it, I was like, I didn't look at it that way. 7/9 x minus 4/9 x, and I missed my x, there we go, equals 1/4 plus 5/12. I go, well, these two have the same denominator, so I can just combine those. 7/9 minus 4/9 is 3/9 x, and 3/9 could be simplified to 1/3. On the other side, 1/4 plus 5/12. Well, to add those together, I need to change the fourths to twelfths. To do that, I would take 1/4 and multiply by 3/3. So 3 times 4 gives me that 12 on the bottom that I need, and 1 times 3 is 3 on top. So 3/12. Okay, so 3/12 plus 5/12. So 1/3 x equals, I'm just going to add over here, 12ths plus 5/12 would be 8/12, and 8/12 can be simplified to be 2/3. Get rid of that 1/3 on the left. I need to multiply by the reciprocal, which is 3. I multiply both sides by that. So the 3's here, they all cancel out, and you're just left with, zoom out a little bit, and you can see the next problem. Oh well. X on the left, and then 2/3 times 3. Those 3's cancel out, and you're just left with 2. X equals 2. I didn't think that was that, crazy of a fraction problem, because again, you've got the same denominator on the left. This just needs to change, and then they both simplify to be thirds. So it's not the craziest fraction problem I saw. The thing that they did on the College Board on their website, what they did was get rid of the fractions in the first round. So the College Board said is, okay, to get rid of the fraction all the way across, look for the least common multiple of 9, 4, and 12, which would be 36. And so multiply everything by 36, each one of these individually by 36, and that gets rid of all the fractions. Sure. I think that is, that obviously works. That is a way to do it. I think that's prone to more error. I think it's easier to make mistakes when you're doing that. But okay, let's do it their way. If we multiply 7/9 by 36, because you view this as 36 over 1, then the 9 and the 36, that's going to leave 1, that's going to leave 4. So 4 times 7 would be 28. So 28x. Here, 36 over 1 times -4/9. Again, the 36 and the 9, that becomes 1, that becomes 4. 4 times 4 is 16. 16x. On this side, 36 times 1/4. What's a fourth of 36? Or 36 divided by 4 is 9. And then 36 times 5/12. You can use canceling. 12 goes into 12 one time, into 36 three times. 3 times 5, so what's left is 15. And then you get 28x minus 16x, which would be 12x, equals 9 plus 15, which is 24. And when you divide both sides by 12, you are left with x equals 2. If that's easier to you, getting rid of those fractions with that 36 and then multiplying it by those, multiplying all those fractions by 36 to get rid of them. Yeah, it's just your preference. Your mileage may vary. Personally, I prefer, because the fractions aren't that crazy, just dealing with them as they are and not doing that. I think it's too easy to make mistakes, but, that's my opinion. Do whatever you want. Right, number 18, another figure not drawn to scale. Watch out for these. Two isosceles triangles are shown above. If 180 minus z equals 2y and y equals 75, what is the value of x? I'm going to make this bigger. Let's really, so we can draw on this puppy. Why are they called puppies? I don't know. So two isosceles triangles, and they've indicated it with their little, their little hashtag marks there, their little hash lines. If 180 minus z equals 2y. All right, 180 minus z equals 2y. And y equals 75. Well, they've told us what y equals. We can solve for z. First thing, that's what I'm going to do. So I go, oh, if y is 75, I can just plug it right in there. So let's do that. 180 minus z equals 2 times 75. 2 times 75 is 150. Then I'm going to subtract 150 from both sides. And I get 30 minus z equals 0. So 30 minus what equals 0? 30. I can go through all the algebra steps, but that one, you just want you to think about that. Go, 30 minus what would equal 0? 30, right? So z equals 30. Okay, so now I know right there, this is 30. At this point, this y and this triangle, honestly, the fact that y is an isosceles triangle is part of it, it's irrelevant. It doesn't matter at all. All you needed that y for was to tell you it was 75 and then to plug it into that number. That's it. You don't need it anymore. Now, all we need to look at is that this is an isosceles triangle and the top angle here is 30. An isosceles triangle, oh, come on, it's not letting me change to an eraser. There we go. So an isosceles triangle, the big takeaway with an isosceles triangle that you need to know for this is that the base angles are congruent, always. So if this, I just rotated it. So if this top angle up here, this is angle Z, if this is 30, and these are both, congruent angles, how do I find that? Well, 180 degrees total is what all these three add up to in a triangle. So what happens if I get rid of that 30 degrees? I get 150 left. So these two together equal 150, and they're identical. So you could say that as like x plus x equals, and actually let's not use x because We already have an x there, and I don't want to do that. Let's call it a. So I have a plus a equals 150. I have two a's. So 150 is going to be divided by 2. It's 75. So each of these is 75 degrees. If you want to see that written out, 2a equals 150, and you divide both sides. I'm running out of room. Divide both sides by 2a equals 75. There it is written out. So now look back at our picture, and I know this angle right here in the corner that this is 75. Well, it is making a straight line with x. So I'm going to go over here. I'm going to rotate that out. So I've got this triangle, and this is, we've said, is 75 degrees. And this is x. And together they are making a straight line. A straight line has 180 degrees. So if I take away that 75, I will know what x is. So 180 minus 75 equals 105, and that is my value for x. Number 19. At a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? I'm going to start putting these into an equation form just to rewrite this and get it out of word problem form so I can see what is going on. So each hamburger, I'm going to use a variable h, has 50 more calories than the fries. So the number of calories in h, that's what the number of calories in a hamburger, that's what h is representing. It's a calories in a fry plus 50, 50 more than the fries. Okay, so that's what I've got from that first sentence. Then we're told if 2 hamburgers and 3 orders of fries have a total, so I'm adding, of 1,700, how many calories does a hamburger have? This is a system of equations. Systems of equations can be solved most commonly by using graphing, substitution, or elimination. Graphing I would not recommend. We've got these big numbers here. No. Plus, you don't have a calculator. Elimination we could do, but substitution is right there smacking us in the face. Like, do substitution, because we already have h by itself being equal to f plus 50. So I'm going to take this f plus 50 and plug it in for h. So it's 2 times f plus 50 plus 3f equals 1,700. So I need to distribute 2 times f and then 2 times 50. 2 times f would be 2f. Sorry, that little, get rid of that. Go away, ruler. 2f, and then 2 times 50 is 100, plus 3f equals 1,700. And I'm going to combine those. I'm going to combine these like terms. 2f plus 3f is 5f plus 100 equals 1,700. Then I'm going to subtract 100 from both sides. And I get 5f equals 1,600. I'm going to just slide it up a little bit because I'm just running out of room. Just slide it up and I'll zoom back out in a second. All right, so I need to divide both sides by 5 to get rid of that 5. So f is equal to, what is that, 320? So an order of fries has 320 calories. But is that what they asked? No, it isn't. This is where we have to be very, very careful. Let's go back up to the top. It says, how many calories does a hamburger have? Well, the hamburger is the fries plus 50. So we've said the fries are 320 calories. So it's going to be 320 plus 50. So the hamburger has 370 calories. Number 20, in triangle ABC, the measure of angle B is 90, BC is 16, and AC is 20. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, and C respectively, and each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of sine F? There is so much verbiage here, and it's not all necessary. They are messing with you. All right, so first thing, anytime they're describing any geometric shape, I'm going to start drawing immediately. Triangle ABC, they tell us the measure of angle B is 90 degrees. Okay, a right triangle. So I'm going to draw myself a right triangle. A, B, C, and B is my right angle. Done. BC is 16. Okay, so I'm going to write that on my picture. AC is 20. 20. Okay. Right off, this is something I want you to know. I want you to ingrain it in your head. Right triangles, the most common right triangle you're ever going to see is a 3, 4, 5 right triangle over and over and over again. There are some others like a 5, 12, 13. That's another one that shows up, but not as common as the 3, 4, 5. 3, 4, 5 right triangles are like the oldest ones we have. If you're going back historically, you see evidence of 3, 4, 5 right triangles being used thousands of years ago in construction and such. It also applies to any multiples of this. So if it's 5 times 4, then this side would be 4 times 4. This other side would be 3 times 4. It's still a right triangle. So when I look at this and I go, 20 is 4 times 5. Wait, 16 is 4 times 4. This is 4 times 4, 5 times the same number. This side must be 3 times 4, or 12. It is a multiple of a 3, 4, 5 right triangle. That kind of thing, of recognizing that, will help you so much on these kind of tests. So that is helpful here. If you can recognize that, it's great. So 3 times 4, or 12, is my other side. So I do not have to do the whole 16 squared plus a squared equals 20 squared and solve for that without a calculator. Yeah, you don't want to be doing that on a test. It's your last problem and you're frantically trying to get it done. Right, so we're told there's another triangle, DEF, that is similar to it. So it has the same angles, but is proportionally either bigger or smaller. So DEF, it is similar to it. And then it says, each side of triangle DEF is 1/3 the length of the corresponding side of angle ABC. That sentence, or that phrase, that clause, is irrelevant. It doesn't matter at all. It is just because they want you to take 1/3 of 20 and 1/3 of 16. What? No, you do not need that at all. What is the value of sine F? Sine F. These triangles are similar. Similar triangles always will have corresponding angles are congruent. Always. It's the definition. It's in the definition of similar triangles. So the sine of F, the sine of an angle of a certain degree, is always the same no matter how big or small the triangle it is in. So the sine of 45 degrees, it will be the same if it's a teeny tiny triangle or a huge triangle. That's what trig is all about. That's what sine, cosine, and tangent are all about. So the sine of angle F is going to be the same as the sine of angle C. It just is. You don't have to do, it's 1/3, so what's 1/3 of 20? No, you do not have to do that. That's ridiculous. They're just trying to mess you up and make you waste time. So the sine of angle C. Sine is equal to the length of the opposite, divided by the length of the hypotenuse. Opposite over hypotenuse. So the opposite side from C is 12, and the hypotenuse is 20. And you can simplify that down to be 3/5, because it was just like a 3, 4, 5 right triangle, opposite over hypotenuse C, 3, 4, 5. It's a good thing to know. Because if you realize it's a 3, 4, 5, you just jump straight to that and say, 3/5. Don't even have to simplify afterwards. And you didn't have to do all that Pythagorean theorem to figure out that that was 12. So the sine of angle F over here is the same as the sine of angle C, which again is opposite divided by hypotenuse, 12/20, which simplifies to 3/5, which is your answer. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.